Welcome to David Alexander Maths Tuition. This is chapter 7a on the addition formulae. Okay, so what I'm going to do here is just show you the proof of the addition formulae. So what I've got here is a square, or it could be a rectangle, it doesn't really matter. But the key thing is I've got two right angled triangles inside it, and the hypotenuse of this triangle on top is 1 unit. Now I'm going to label these angles as angle A on the lower one and angle B on the one above it, or B and A can be the other way around, it doesn't really matter. Okay, so what I'm going to do is try and label every side and every angle. So here I've got another 90 degree angle, and here another 90 degree angle. So this side length here, how could I write that? So what I could say is that the cos of B is this side, which is currently called x, is x divided by 1. So if I multiply through by 1, then I get that cos B is x. So this side here I can write as cos B. Similarly, the side opposite I can write as sine B. Okay, now if I know that the hypotenuse of the triangle on the bottom is cos B, then that means that A, well, what is A? So again, if I could, well, sorry, what A is the angle. What is the length of this side here, which I'll just call x? So what I can say is that the cos of A is x over cos B, because the cos of the angle is the adjacent divided by the hypotenuse. So therefore, if I multiply through by cos B, then cos A, cos B is my x. So this side here is going to be cos A, cos B, and this side length here, this is going to be sine A, cos B. Okay, so let's have a look at some of the other angles. So this angle here is going to be 90 take away A. This angle here is going to be 180 minus 90 minus 90 minus A. In other words, it's going to be 90 minus 90 minus A. In other words, 90 minus 90 plus A. In other words, A. So this is also angle A. Here we would have a 90 minus A. Not sure if that helps us massively at the moment. So given that I know that the hypotenuse of this small triangle in the top right corner is sine B, then this side length here is going to be cos A sine B. And the side length along the top, that is going to be sine A sine B. Okay, right, what else can we do here? So let's have a look at this larger triangle on the left. So this big angle here is A plus B. So this angle here is going to be 90 minus A plus B. So this is 90 minus A minus B. Okay, not massively helpful. 90 minus A minus B. Now this angle up here, this is going to be 90 or 180 minus 90 minus 90 minus A minus B. So if, in other words, it's 90 minus 90 minus A minus B. So if I do 90 minus 90 minus A minus B, that becomes 90 minus 90 plus A plus B. So A plus B. So this angle here is A plus B. Okay, so this top side up here, we can label that the cos of A plus B is this side divided by 1. In other words, this side here is going to be the cos of A plus B. And this side length down here, this is the sine of A plus B. Okay, so it's all looking very messy at the moment, so I'm just going to tidy the board up a little bit. Okay, that's much better. So now what I've done is I have proven these addition formulae. So because it's a rectangle or a square, this side length here is the same as this side length from top to bottom on the other side. So what we can say is that the sine of A plus B, that is therefore sine A cos B plus cos A sine B. There we go. So that is one of these addition formulae. Knowing that sine of A plus B is sine A cos B plus cos A sine B. You might want to write it as sine A cos B plus sine B cos A. Doesn't really matter, of course. Okay, now the other one is we know that this side here is exactly the same length as this side here. So what we can say is that cos A cos B, that is the same as the cos of A plus B plus sine A sine B. Now we would normally rearrange this so that we've got the cos of A plus B in the same way that we had the sine of A plus B as the subject of the other equation. So all I'm going to do is I'm going to subtract the sine A sine B from both sides. So what we can say is that the cos of A plus B is cos A cos B, take away sine A sine B, and this is the second addition formula. Okay, so for sine it's nice and easy. It's the sine of the first bit, cos of the second bit, plus cos of the first bit, sine of the second bit. If this is a negative sign, then this would simply be a minus sign here. Now with cos of A plus B, it's slightly different. It's cos of the first thing, cos of the second thing, and then the sign is the opposite. So as this is plus B, this becomes minus, and then it's sine of the first bit, sine of the second bit. If this was cos of A minus B, then it'd be cos A cos B plus sine A sine B. So all I've done here is, in a long-winded way, just shown you a proof as to where these addition formulae come from. They are given to you in the formula booklet, but just remember the sine of A plus B is sine A cos B plus cos A sine B, or sine B cos A. And the cos of A plus B is cos A cos B minus sine A sine B. There we go, and we're done. Okay, so here are the addition formulae written out a little bit more clearly. Now, what about the tan of A plus B? Now, the tan of A plus B is the sine of A plus B divided by the cos of A plus B. Remember that sine divided by cos is tan. Now, if the sine of A plus B is sine A cos B plus cos A sine B, then let me just write that down. So sine A cos B plus cos A sine B, and that is going to be divided by the cos of A plus B, which is cos A cos B minus sine A sine B. So what I'm going to do is I'm going to divide, that looks is a C, not a sine, there we go. Anyway, I think we know what's going on there. What I'm going to do is divide each of these little bits by cos A cos B. And then we can see how we get this tan of A plus B. So remembering, of course, that sine divided by cos is tan. Sine A cos B over cos A cos B, well, the cos B's will cancel. Sine A over cos A, well, that is the same as tan A. Cos A sine B over cos A cos B, well, the cos A's will cancel. Sine B over cos B, that is tan B. And there's a plus sign in between, of course. Cos A cos B over cos A cos B, well, that is, they both will cancel, so that will just give us the 1. Subtract or minus. Sine A sine B over cos A cos B, well, sine A over cos A, that is a tan A. Sine B over cos B is the tan B. So this is how we get the tan of A plus B. So the tan of A plus B is tan A plus tan B over 1 minus tan A tan B, and the tan of A take away B is tan A take tan B over 1 plus tan A tan B. So note there is a different sign on the top and the bottom. So that's just something to be careful of. And again, all these formulae are given to you in the exam. So chapter 7a, there's not really much that's of real interest, more an understanding of where these addition formulae come from. You may not be very interested where they come from, but you can see why they work. And here they are. And for the rest of the chapter, or the rest of the sub-chapters in chapter 7, we're just going to be using them, putting them into practice. Okay, so we're moving on to some of these fiddly little questions that are in the book. You'd never be asked in an exam simply, what is this? But this could be something that might unlock a question which would help you develop it further. So you need to recognise that as it's sine 23 cos 57, and then the other part is the same angle values, but one's the sine one has become a cos one, that is therefore the same as, well, this is the sine of A plus B, so here it would be the sine of 23 plus 57. So if I said to you, okay, using the addition formula, write out the sine of 23 plus 57, you'd know it would be sine of the first one, cos of the second one, which is this, plus cos of the first one, sine of the second one, which is that. So the sine of 23 plus 57, well, that is simply another way of saying that this is the sine of 80, which I'm sure you'll agree, writing the sine of 80 is much less complicated than writing this or this ugly stuff. This second one, we can see that this is going to be the cos of A plus B, because it's a minus sign. Remember the addition formula for cos, you swap the sign. So if the first value is 32, the second value is 42, then we get cos 32 cos 42. Here we go. Subtract sine 32 sine 42. There we go. So this is the same as the cos of 32 plus 42, and the cos of 32 plus 42 is of course the cos of 74. Here we've got this is going to be a similar one, but this is going to be the cos of A take away B. So that's going to be the cos of 28 minus 12, which is the same as the cos of 16. And for this one, we need to recognise this is the tan double angle formula. So this is a way of writing the tan of A plus B, where A would be 32 and B would be 11. So this is the tan of 32 plus 11, and 32 plus 11 is 43. So that we can simplify that to simply writing it as the tan of 43. Okay, so this is a question that kind of looks much more complicated than it is. And the key thing is that x equals y equals theta. So all of these x's and y's and theta, they are the same thing. So what I can do is I can replace the x and the y with a theta. So another way of writing the cos of x minus y is to write it as cos of theta take away theta. Now, actually, if we just pause and think of it, let's say theta was, well, let's give it a value of 82 or whatever. 82 minus 82 is 0. In fact, whatever I say theta is going to be, theta minus theta will be 0. And of course, the cos of 0 is 1. If you think of our cos graph like so, the cos of 0 is 1. So it kind of makes sense that this is going to be 1. Okay, so but how can I show that the sine squared plus cos squared theta is always equal to 1? Okay, so what I'm going to do is I'm going to do my double angle, my addition formula here. So the cos of theta take away theta, I can write that as cos theta plus sine theta sine theta. So here that is going to be cos squared theta, and that is going to be a sine squared theta. There we go. So I can say therefore that sine squared theta plus cos squared theta is always the equivalent to 1. And again, we could probably just write down therefore cos of theta minus theta, that is the cos of 0, and the cos of 0 equals 1. There we go. So we've shown that sine squared plus cos squared is always equal to 1. Write sine of x plus pi over 4 in the form of root a over a sine x plus cos x. Okay, where a is a constant to be found. Right, so what we can do is we can expand this using the addition formula. So that's going to be sine x cos pi over 4 plus cos x sine pi over 4. Okay, so if I think of my triangle, so 1, 1, this is a root 2. I'm just using this to work out the what pi over 4 is, the cos of and the sine of pi over 4 is. I mean, you could use a calculator, of course. Now, the cos of pi over 4 is 1 over root 2. So that's 1 over root 2 sine x, plus the sine of pi over 4 is also 1 over root 2. So that's 1 over root 2 cos x. So I can write that as 1 over root 2 sine x plus cos x by factoring out the 1 root 2 and 1 over root 2, rationalising the denominator, that becomes root 2 over 2 sine x plus cos x. There we go. So a is simply 2. Okay, here's another example that's quite similar to the one before. So using the addition formula, I'm going to write this in a different way, so I can say that that is cos x cos pi over 6. Subtract, remember the cos addition formula, you change the sign, sin x sine pi over 6. So you could use your calculator. I tend to find it easier just using the triangles. 1 to root 3. So pi over 6 is this angle here. Okay, so the cos of pi over 6 is root 3 over 2. So that is going to be root 3 over 2 times cos x minus, now the sine of pi over 6 is 1/2. So that's going to be 1/2 times sine x. So 1/2 sine x. Okay, so what we want to do is we want 1 over something, so maybe if I can take out a half, so let's factor out 1/2, so that's 1/2 lots of root 3 cos x minus 1 sine x, and if you're not sure if that's correct, then just expand these brackets mentally, just check that that is definitely root 3 over 2 and minus 1 over 2, and it is. So we can clearly see that A is going to be 2 and B is 3. Okay, here's another example that looks a little bit mysterious. So we've been told that the sine of x equals the cos of x minus y, and we need to show that the tan of x equals some other stuff. Okay, so we've got the opportunity here to use our addition formula. So we can say that the sine of x equals cos x cos y plus sine x sine y. Now, given that I'm aiming for a tan x, well, I've got an equation in terms of sine x. So if I just divide through by cos x, then maybe I'll certainly get a tan x at the front. Let's see what happens to the rest of the stuff. So we know that sine x over cos x, that gives us the tan x, which we're after. Cos x cos y over cos x, well, the cos x is cancelled to give us cos y. And on the other side here, we've got sine x over cos x, which is the tan x, sine y, and we have got, well, we've got what we need. I seem to recall that in the book the example's a little bit more complicated than that, but it's effectively the same thing. Use your addition formula and look for opportunities to divide through by a cos x or a cos y, just to eliminate certain parts and to turn some sine related things into tan related things. Okay, so here's one final example. So we've been told that the tan of x plus y equals 7, and we want to express tan y in terms of tan x. So again, it's not obvious where we're going from here, but we've got an opportunity here to use our addition formula, which is the tan of x plus tan y over 1 plus tan x tan y, and we know that that equals 7. So to me, the obvious thing to do would be to multiply through by 1 plus tan x tan y. So we'll get tan x plus tan y equals 7 lots of this stuff here. So that'd be 7 plus 7 tan x tan y. Now, as we want tan y in terms of tan x, then I'm going to subtract a tan x from both, a tan y from both sides. So I'll just get rid of that and put a minus tan y over here, and I'll move the 7 to the other side. So what I have is tan x minus 7 equals 7 tan x tan y minus tan y. Now on the right hand side, I can factor out a tan y. So I can say that tan y lots of 7 tan x take away 1 equals the tan x minus 7. And now just divide through by 7 tan x take 1. So therefore the tan of y is the tan of x take away 7 all over 7 tan x minus 1. Oops. So there I have it. I've got tan y in terms of tan x.